Welcome to a deep dive into the fascinating world of language models. And, we're not just talking about chatbots here today. We're going way deeper into how they actually learn. And get this, researchers are figuring out how these AI models can actually keep track of a changing state of a problem.
Yeah, it's really fascinating because
Yeah.
it resembles a complex game. Like almost like the model needs to remember a series of changes as it goes.
Right. And the researchers actually put these models to the test with something called permutation composition problems.
Right.
Now, that sounds a little intimidating, but just imagine like a deck of cards and it's being shuffled over and over again.
Yeah.
And the model's job is to predict that final order of the cards after all those shuffles.
It is challenging because each shuffle changes the entire state of the deck.
Right.
Right. So the model has to remember not just the individual shuffles, but also how they interact with each other.
It's like a mental juggling act with 52 cards.
Right.
And here's the mind-blowing part. The researchers didn't program the language models with any specific method to solve this.
Yeah.
They essentially said, figure it out yourselves.
Exactly. And that's what makes this research so groundbreaking, because these language models, which are really just algorithms, designed to predict the next word in a sentence, had to come up with their own strategies to solve this really complex problem.
So we have these language models trained on predicting words suddenly thrown into this card game with no rule book.
Right.
Did they just fold?
No, they not only rose to the challenge, but they also did it in a way that surprised the researchers.
Really?
They developed their own unique strategies,
Wow.
each with its own quirks. It's like they're thinking outside the box, or in this case, outside the deck of cards.
Okay, I'm hooked. Tell me more. How did they crack this card shuffling puzzle?
Well, through careful analysis, the researchers discovered two main approaches, or algorithms, if you will, that the language models developed.
Two completely different strategies. This is a showdown.
It is like a showdown. The first one they call the associative algorithm, and it involves grouping actions together in a hierarchical way.
Grouping actions. What does that mean in terms of our card shuffling example?
Okay, so imagine building a pyramid.
Yeah.
Start with pairs of blocks, right? And then combine those pairs into larger structures and so on until you reach the top.
Yeah.
The language models using this strategy essentially figure out how each pair of shuffles affects the deck, and then they combine those paired effects, building up to that final outcome.
So they're breaking down this problem into these smaller, manageable chunks and then building their understanding from the ground up.
Yeah.
Pretty clever.
Right. Now, the second strategy is the parity associative algorithm, and that takes a slightly different approach. It's a two-step process.
Intriguing two steps. What's the first move?
So the first step is a really brilliant shortcut. They determine if the total number of shuffles is even or odd,
Okay.
and this seemingly simple check actually narrows down the possible final arrangements of the cards significantly.
It's like eliminating half the suspects in a mystery just by knowing one crucial detail.
Exactly.
What happens next?
Yeah, it's a clever way to simplify the problem right from the start. Now, the second step involves a process similar to the associative algorithm, where they refine the predictions based on, whether it's even or odd.
So they use this quick trick to narrow things down, and then they really get into the nitty-gritty details. That's fascinating. But, are these two strategies just different paths to the same answer, or do they have different strengths and weaknesses?
That's a great question, and the answer is it depends. The associative algorithm, remember our pyramid building friend, it tends to be more robust. So it can handle longer, more complex sequences of shuffles without getting thrown off.
So it's the reliable workhorse, steady and consistent.
Precisely. On the other hand, the parity associative algorithm,
Yeah.
with that handy shortcut, it's faster for those shorter sequences. So it can zoom to the answer when the problem's not too complicated.
So it's like the sprinter, quick off the mark, but maybe not built for a marathon.
Another great analogy. But here's where it gets even more interesting. The researchers noticed that this shortcut strategy, the PAA, sometimes struggled with those longer sequences, particularly when it came to accurately predicting, the final order of the cards.
So the quick trick wasn't always foolproof. Interesting. Why do you think that is?
Well, it seems like the more complex the problem gets, the more important that careful step-by-step approach of the associative algorithm becomes.
It makes you wonder if there are certain situations where one strategy is clearly better than the other.
Yeah, that's one of the big questions that researchers are exploring. And remember, we're talking about models that were designed to predict the next word in a sentence.
Right.
They weren't explicitly programmed to solve, these kinds of complex problems.
It's amazing that they not only figured out how to solve the problem, but they also developed these different strategies for doing it. It's almost like they're adapting their approach based on the specific challenge in front of them.
Right. And it gets even more mind-boggling. Remember how the researchers just let the models figure things out on their own?
Yeah.
Well, it turns out they could actually influence which strategy the language model preferred.
Wait, they could actually nudge the models toward one strategy or the other. How is that even possible?
They discovered that by giving the models specific training exercises beforehand, they could subtly, kind of push them in a certain direction.
That's incredible. So it's not just about the model's internal structure, it's also about the experiences they have, even if those experiences seem totally unrelated to the task at hand.
Exactly. For instance, they pre-trained some language models on a task that involved identifying topics in a set of documents. Seems completely different from card shuffling, right?
Totally different.
But you know what? This seemingly unrelated exercise actually made those models much more likely to favor the associative algorithm when they were later presented with a card shuffling problem.
So their experience with identifying topics somehow influenced how they approached card shuffling. It's like they learned a general principle that could be applied across different contexts.
It really makes you wonder just how much learning is happening beneath the surface. And it raises an important question for researchers. If we can influence a model's approach to problem solving, how can we do so responsibly?
That's a great point. As we delve deeper into these models' capabilities, we also need to think carefully about the implications. It's not just about what they can do, but also about how we guide their development and application.
Absolutely. We need to ensure that we're steering this powerful technology in a direction that benefits humanity.
You've given us a lot to think about already, and I'm sure there's even more to uncover. What else did these researchers find?
Well, they made another fascinating discovery, this time about the parity associative algorithm, that shortcut strategy.
Yeah.
It seems that it's not just a simple calculation happening in the model. They observed evidence suggesting that the models might actually be forming mental representations of the problem.
Well, mental representations, what does that even mean in the context of a language model? Are you saying they're visualizing the cards being shuffled?
It's not exactly like seeing a picture in their minds, but the researchers found that these models were able to cluster groups of cards together based on specific characteristics. They were essentially creating categories or concepts suggesting a level of abstract thinking.
So they're not just crunching numbers, they're forming a sort of conceptual understanding of the information. That's wild.
Right, and this ability to form these abstract representations seems to play a key role in their success in solving these permutation problems. It's like they're building a mental model of the task, which allows them to make more sophisticated predictions.
This is blowing my mind. So we've got language models that are not only adapting their strategies and developing shortcuts, but they're also potentially forming abstract representations to tackle these complex problems. It makes you wonder, what are the limits of their learning abilities?
That's the million-dollar question. And the truly exciting part is we're just scratching the surface of what these models are capable of. As we continue to research and understand how they learn, who knows what other incredible abilities we'll uncover.
Okay, I think we need a moment to process all of this. We've uncovered some truly remarkable insights today. But before we get carried away by all the possibilities, let's take a step back and consider what these findings really mean for the future of AI. Stay with us.
Okay, so let's try and wrap our heads around all that we've learned today. We started with these language models, designed to just predict the next word, and now we're talking about them potentially forming abstract representations and solving all these complex problems. It's like we've entered this whole new dimension of AI.
It's a real shift in perspective, for sure. We're moving beyond this idea of language models as just sophisticated pattern matchers, and we're starting to see their potential for, a much deeper level of understanding and reasoning.
It's exciting and maybe a little intimidating at the same time.
Yeah.
So if we're now seeing that these language models can just spontaneously develop these problem-solving techniques, what does that mean for the future of AI? Well, it really challenges our assumptions about how these models actually learn and what they're capable of. We used to think of them as tools that, needed very specific instructions for every task. But these findings suggest that they have a much greater capacity for learning and adapting than we originally thought.
So they're not just these passive machines following orders, they're more like students who can actually figure things out on their own. That opens up a whole world of possibilities, doesn't it?
It does. If they can solve complex problems like these permutation puzzles without explicit programming, imagine what else they might be able to learn. It begs the question, what are the limits of their abilities?
It's both exciting and a bit daunting to think about. It's like we've unlocked a door to this vast, uncharted territory.
Exactly. And as we venture into this new territory, it's crucial that we proceed with caution and a deep sense of responsibility. As these models become more sophisticated, we need to make sure we're developing them and using them in ways that benefit humanity.
It's like we're explorers setting sail for a new world. We need to have a clear sense of direction and a commitment to using our discoveries for good.
I like that analogy. It highlights the need for, thoughtful and ethical considerations as we continue to advance AI technology. We have a responsibility to understand these models, how they make decisions, and how we can ensure those decisions align with our values.
So, as we marvel at all the amazing capabilities of these language models, we also need to be aware of the potential risks and challenges. It's a delicate balance, wouldn't you say?
Absolutely. Transparency and accountability are crucial. We need to develop ways to understand how these models arrive at their conclusions and to identify any potential biases. It's about ensuring that these powerful tools are used responsibly and ethically.
Well, this deep dive has certainly given us a lot to ponder. We've uncovered some really groundbreaking research that's changing how we think about language models and their potential.
We've seen how they can track the changing state of a problem, how they develop their own clever problem-solving techniques, and even how they might be forming abstract representations of information.
It's been an incredible journey into the cutting edge of AI research.
And it highlights the fact that we are truly at a pivotal moment in the development of AI. The discoveries being made today will shape the future of this technology and its impact on our world.
So, as we wrap up this deep dive, we leave you with a final thought to consider. What does it mean that language models designed simply to predict the next word are showing these signs of, complex reasoning and problem-solving abilities? Does it hint at a deeper understanding than we ever imagined?
It's a question that researchers are grappling with right now, and the answers will have profound implications. We encourage you to continue exploring this topic and stay engaged in the conversation about the future of AI. It's a fascinating and rapidly evolving field with the potential to reshape our world in remarkable ways.
Thanks for joining us on this incredible adventure into the world of language models. Until next time, keep those minds curious.